Hello everyone, welcome to Jerematics Tutoring. In this video, I'll be talking to you about inequalities. There are four inequality symbols. There is one that looks like this, and this means greater than. There's one that looks like this with a solid line underneath that means greater than or equal to. There's another symbol over here that means lesser than. There's another symbol over here that means lesser than or equal to. If it has a solid line underneath the same inequality, that means lesser than. This may seem confusing to you right now, but I just wanted to introduce you to all these symbols before I discuss each symbol one by one. Really, it's all the same idea. The first example I'll be giving you is 5 and then 2. And which symbol is this? This is the greater than symbol, and this makes sense because 5 is greater than 2. When I talk about inequalities, this is the example I like to give. The inequality is always going to go after the number that's bigger. So I like to compare it to Pac-Man because the symbol's very similar. And I like to say that, okay, well, Pac-Man's always going to go eat the one that's bigger. So since 5 is bigger than 2, he's going to go eat the 5. And since over here 6 is bigger than 3, then he's going to go eat the 6. This means that 3 is less than 6 because 6 is bigger than 3, which makes sense. And up here 5 is bigger than 2. He always goes eat the one that's bigger. Because at Namco, they inject him with some crazy artificial growth hormones and he's always hungry, so he's always going to go eat the bigger one. So that's what these symbols mean. And most times you will not have like a 5 and a 2, you'll have a variable letters. And the teacher's going to ask you, well, what does this mean? So when I'm talking about variable letters, here's what I mean. X is greater than or equal to 2. What does this mean? This means that X is equal to 2, and X can be anything above 2, because X is bigger than 2. As you can see, it's going after the X. It always goes after the one that's bigger, and X is bigger than 2. Another example I can give you is 3. This is the type of inequality that always confuses students. They see a 3 on the other side, and then they see an X and they say, well, what do I do with this? Well, what you do with this is you always read your inequality from left to right. And you would read this as 3 is lesser than or equal to X. And we could actually rearrange this using a bit of logic here. Since 3 is lesser than or equal to X, would it be true to say that X is greater than or equal to 3? Because 3 can be equal to or less than X. So this must mean that X can be equal to 3, and it can be anything above that. So what we can do is we simply reverse this inequality. We bring the X on the other side, and we bring the 3 on the other side, and we flip the symbol over. X is greater than or equal to 3. Same idea, because if you're going to grab each thing on both sides of the inequality, and you're going to flip them over, it makes sense that you flip the inequality. There's an explanation for this, which I can actually show you right now. So there's a rule that states that if you ever multiply by a negative number, you flip your inequality over. So for example, negative x is greater than 2. When we ask you to solve an inequality, we always want it to be in terms of x, with no negatives, with no coefficients in front. We do this by dividing both sides by negative 1. And then we need to remember that we always flip this inequality over whenever we divide by a negative or multiply by a negative, because, you know, your biggest mistake would be to forget to flip over the inequality when you divide by a negative 1. Because think about it. Say we got a negative 3 over here, and we say negative 3 is less than 4. And now, let's go with negative 5. Negative 5 is less than 4. Now let's divide both sides by negative 1 and see what happens. You get 5 is less than negative 4. This doesn't make any sense because 5 is bigger than negative 4. How can negative 4 be bigger than 5? It's not. That's why you have to flip the inequality over, because watch. Then it makes sense. You will get 5 is greater than negative 4. Is this true? Yes, it is. So using this logic, we can conclude that, yeah, whenever we divide by negative 1, we must flip our inequality over. I will give you a few more examples of reading inequalities, and that will be the end of this video. X. What do you think this means? This means x is lesser than or equal to 3. Y. X is lesser than or equal to 3y. Which one's bigger? 3y. So we can actually rewrite this as 3y is greater than or equal to x. Because if you move both sides of the inequality and swap them, then you must flip your inequality over to, it must be pointing at the one who was originally pointing at before you rearranged everything. That's how that part works. I'll show you a few examples involving negatives once again, just to make sure that you got the idea. So negative x is greater than or equal to 5. Solving for x, we need to divide both sides by negative 1. This will give us x is lesser than or equal to 5, negative 5. So x is lesser than or equal to negative 5. So this means that negative 5 is greater than or equal to x. So this must mean that x is always a negative number because it needs to be less than negative 5. And all the numbers that are less than negative 5 are all negative. So that's what that means. Another example I will give you will involve like a bit of arithmetic, like you need to add to both sides or subtract just to solve for x. So let's go negative x plus 3 is lesser than or equal to 2. The first step we do is we need to subtract 3 from both sides. Lesser than or equal to 2 minus 3. And then now we divide both sides by negative 1. So negative x is lesser than or equal to negative 1. And then we divide both sides by negative 1. Negative 1 divided by negative 1 is 1, because a negative divided by a negative is positive, and 1 divided by 1 is 1. This gives us x is greater than or equal to 1. Does this make sense? Let's test it out. If we plug a 1 in here, we get negative 1 plus 3, and we get 2. Is 2 lesser than or equal to 2? Yes, it's good as equal to 2. Now if we plug in a 2, we get negative 2 plus 3, negative 1. Is that less than 2? Yes, it is. So this means that our inequality is true. Because the whole point of these inequalities is not one value that satisfies these things. There's an infinite number of values that can actually satisfy this inequality. Like you can plug in 1.1, 1.111, 1.2, 1.22, 1.3, 1.4, 1.5, 1.666, 1.333, 1.444, and so on and so forth. You can just keep on plugging anything as long as it makes this inequality true. Thank you for watching, and if you have any comments, feel free to leave them below. And if you like my content and would like to stay up to date, then feel free to subscribe.